Hi everyone, I'm Lindsay and I'm a security engineer at Panther, and today I'm going to talk to you about a new feature called data models. So what is a data model? Basically, it provides a way to translate a unified field name into a log type specific field name. So what do I mean by that? Well, in your environment, you're probably collecting logs from many different sources, probably span different vendors. They're all going to represent data in slightly different ways. It's because they developed their logging infrastructure separately. This is where the power of data models comes in. I can say, hey, give me the source IP address from this event. And on the back end, there could be a translator, the data model, that says, oh, this is an Nginx log. And I know how Nginx represents the source IP address, so I'm going to return the appropriate value. If instead it's a DNS event, there could be a data model for that DNS log type that says, oh, she asked for the source IP address. Well, I know how this DNS log represents that field, so I'm going to return the appropriate value for it. So this is really powerful because it means I can create alerting and detections generically that apply to many different log types. So I think to really understand and grasp this, it'd be a good idea to look at an example. And in this example, we're going to look at web logs, but this can apply to many different cases, not just web logging. So let's say you've been given a user agent string that is suspicious, and you want to find any instances of that string across your entire environment. Let's say you have Nginx running. You know Nginx represents the user agent field by HTTP user agent. Let's say you also have Apache running, and Apache logs the user agent string in the user_agent field. You could also have some custom web logging infrastructure that says actually logs the user agent field in something just called UA. Well, how are we going to write a detection across all of these? Our first option is to create a rule that becomes pretty complicated because we have to say if user agent is equal to this suspicious string, or HTTP user agent is equal to this suspicious string, or UA is equal to the suspicious string. Or we can use data models to do a translation for us, and we don't have to deal with that complex and cumbersome detection logic. So here we have Panther running. We can go into our detections tab. I've already created a suspicious user agent rule, and right now it's only applying to the Apache log type. So let's say we want to be monitoring our Nginx logs as well. So let's go and create a data model for Nginx. So let's go to log analysis data models. We'll create this new data model. We'll call it Nginx access logs. We'll give it a unique ID. We'll say Nginx access.data model. So every data model has to have a unique identifier. This data model is going to apply to the Nginx access log type. Now, under this data model mapping section is really where the power comes from. This is where that translation happens. We're going to say the unified field name is user_agent. And in Nginx, I know it represents the user agent field with HTTP user agent. So this is where that translation happens. Unified field name, user agent, gets translated, if this is an Nginx log event, into HTTP user agent on the back end. So let's save this. And now we can find it in our list. Our Nginx access logs data model applies to the Nginx access log type, and it is enabled. We can go back in and see exactly that it saved our values in there. So now let's go back to our detection for our suspicious user agent, and let's apply it to Nginx. And we can just hit update. We're good, right? Well, we might want to test that it's actually working. So let's actually look at the rule logic itself. So what is this rule doing? It's taking in an event, a log event, and it's running this UDM method. What is that? Well, dictionaries in Python have the .get method that will return values in the dictionary based off what key you give it. We introduced this UDM method, so unified data model method, that says, you can pass in the unified field name in our case, user agent, and it's going to return the appropriate value for that event using the data model for translation. So that's what this is saying. We're getting a log event. Give me the user agent field for that log event. And if that user agent includes the substring burp in it, trigger an alert. So right now we have two test cases here, and this was for the Apache log type that this was already applying to. So you can see the log type is Apache access combined. In this case, this is a no match case. It shouldn't trigger an alert, and that's because the user agent field doesn't have burp in the string. So there was also an Apache match case. So we have Apache access combined here, same log type. But now the user agent field should trigger an alert because it has burp in the string. So let's run these tests. Yep, works, it's great. But we wanted to test our new Nginx data model. So let's create a couple new tests. In our first test, we want to see if it will trigger an alert because the user agent field contains burp in the string. So we'll call this Nginx match. And this is the sample log event where we see it's an Nginx log event, and it's calling the user agent field HTTP user agent. And this should trigger an alert because it has burp in the substring. Now, if you'll note, we're using the Nginx language here. Nginx is logging in this field name, but in our rule, we're using the unified field name user_agent. So we're going to be able to see if our data model was successfully saved and is doing that translation for us on the back end, translating user agent into the Nginx language of HTTP user agent. So let's create a second test as well, one that shouldn't trigger an alert. Call it Nginx no match. And it'll just be the opposite test case, one in which the user agent string does not contain burp, so it should not trigger an alert. And again, the log type of Nginx access. So let's run these test cases and see if they pass. So let's run them. And we see test Nginx match is triggering an alert. It's appropriately filling in the alert title in the alert deduplication string. And the no match also passes. It doesn't trigger an alert because it didn't contain the burp in the user agent field. So we know our data model is working appropriately. It's translating on the back end as we want it to. And now this rule we know can apply to any new weblogs. So if we have more weblogs that we want to catch this user agent string in, all we have to do, create the data model for it and add that log type to this detection. It's pretty powerful. It's pretty cool. In our open source Panther analysis repo, you can see some of the data models we've provided. They span many different log types, including AWS, Box, GCP. And in these, you can see some of the advanced features of data models that we didn't go into. So in our example, we did just one strict field-to-field mapping. The log type you're dealing with has some nested fields in it. You can actually access them using JSON paths instead of just a strict field name, which is what's happening here. And then also, if you want to define some more complex logic to determine what a field should be in a log, you can define arbitrary Python for it as well. So that's what this is doing here. This event type is actually being returned from a method. So we have a get event type method. It's defined down here, and it's going to return the event type for this log event. So those are some of the advanced features you can look into, some of the data models that we provide. We also have a few out-of-the-box detections that rely on these data models as well. So in summary, what is a data model? Why would you care? Data model, again, provides a translation between a unified field name into a log type specific field name. And this is pretty powerful because you can quickly get value out of the box for any new log types you add to your environment, because you just have to add that data model for that log type and then apply that log type to your detections. It reduces duplication. So as we were talking about earlier, there were two options you had when you wanted to detect a suspicious user agent in your environment. The first one is to create a really long and complex rule that says, if HTTP user agent is equal to the suspicious string, or user agent is equal to the suspicious string, or UA is equal. You could also separate that out into multiple different detections and say, if this is an Nginx log, I have a specific detection for it. If it's an Apache log, I have a specific detection for it. But it's a lot of duplication, a lot of complexity. With data models, you create one detection that says, give me the user agent field and alert me if it's suspicious. And the data model actually does the translation for you. So you don't have any duplication of alert or detection logic there. And then finally, you can separate each of these log types into they're all separated logically into their own data model. So you kind of keep the context in your mind. You're only dealing with one log type at a time, and you can provide the translation one at a time rather than having to know exactly how each log type represents a field all at once. You don't have to know, this is how Nginx does it, this is how Apache, this is how my custom. You're just dealing with, oh, I have a custom web log here. I know all of its fields, and I can just do that one-to-one translation for it. And then I can move on to the next one. And you don't have to keep so many different contexts in your mind at once. So I think this is a really cool feature, and I'm excited to hear how you're using it and how you like it.